Ladies and gentlemen, I'm pleased to welcome you to the session on the European Green Deal as part of the German EU Presidency Conference IndTech. The Green Deal announced by President von der Leyen in December 2019 has the ambition that is matched with the present call, which is nearly €1 billion. Its goal is to use research and innovation to kickstart the environmental, social and economic transformation required to tackle the climate challenge that we are all facing. Science, knowledge and evidence provide the basis for the design of new green growth strategy for the EU, whereby enhancing Europe's competitiveness. And the challenge is not just technical. It requires a profound adaptation in lifestyle and behavior. And research and innovation offers unique opportunities in this regard to reach out and to engage with Europe's citizens in novel ways with a view to ensure that no one is left behind by the transition. This is a monumental task, and we need the industry to take the lead in order for this to become a reality. With this introduction, I would like to pass the floor to my co-moderator, Pierre, Joris, the chairman of the A.SPIRE Association behind the the process for Planet PPP. Please, Pierre, the floor is yours.
Thank you, Soren, and again, good morning to everyone. This is indeed a very important topic, very close to my heart as president of A.SPIRE, the way these industries can really support and participate to this transition to sustainable prosperity. Now, in the session of today, we will listen to 4 distinguished speakers to understand their views about these challenges. We will have then some time together for panel discussion where I encourage everyone to raise their own questions. There will be at the same time a poll that Soren will animate. Now, without further waiting, I would like to introduce the first speaker of today, Barend Verachtert. Barend Verachtert is head of the Materials of Tomorrow unit in in DGRTD of the European Commission. The unit is in charge of the development and implementation of the research and innovation policies for advanced materials. Barend has held various positions within DGRTD in the field of SMEs, bioeconomy and agri-food, and he started, as a matter of fact, as interim executive director of the well-known bio-based industries joint undertaking, which is another public-private partnership. So before joining the European Commission, Barend was technology acquisition manager for Plant Genetic Systems in Belgium, a plant biotechnology company, and obtained a PhD in biology from the University of Leuven. So Barend, the floor is yours. I think you are muted.
Thank you so much. Is this better? Thank you. So very happy to be with you this morning, ladies and gentlemen. Delighted indeed, and happy to say a few words about the views of the European Commission on what is the way ahead in terms of the Green Deal. Now, if everything is well, you should see a slide. Yes, indeed. Okay. So then it's hard to believe when less than a year ago this new commission started its work, then evidently the very first major policy initiative which was promoted by this commission was called the European Green Deal. And it was high time that we had it. It is a strategy indeed to ensure that we deal in an appropriate fashion with the impact and the consequences of climate change and how we as a society have to react to that. This European Green Deal, therefore, has set out very clear and ambitious climate goals for 2050. It has set up first years of initiatives around supplying a clean and affordable, secure energy. It's about mobilizing the industry. As Soren already mentioned, the industry is a key stakeholder in this and will become and has to be a part of the solution in order to indeed come up with a clean and circular economy. It's about new ways of building, it's about air pollution, and a range of other things. What is really, really crucial to understand here is that research and innovation have a central role to play in order to deliver on these very ambitious Green Deal policies. So, here they are. And here we have Horizon 2020 and indeed Horizon Europe. A few words more about that a bit later. Now, this was a year ago, and then we all know what happened earlier this year is with the current pandemic, which has struck us, all of us, at the personal level and at the level of society very hard. And the Commission immediately reacted to that with a very ambitious proposal, which we call the recovery package. And the recovery package really set out to mobilize resources available in member states, but also the resources available within the industry, within the economy, and the resources available at the level of European program in order to come up with sustainable solutions to deal with this. Now, what is really again crucial here is that this recovery package is very, very much subscribing and supporting the objectives of the Green Deal, the European Green Deal. And so it is all about investing in a green, digital and resilient Europe. Now, what sort of initiatives have been taken so far under the Green Deal? Well, only 2 weeks ago, on the 14th of October, the Commission announced a whole series of new policy initiatives, and those include the chemical strategy for sustainability. It includes the methane strategy. It also delivers the report on the state of the energy union, and the Commission came out with a very important new initiative, the so-called Bauhaus Initiative, where we will be looking at what we can do in the building sector, in our own living environments, in our own working environments. And that was just a few examples of what has happened, because earlier this year, the Commission has come out with the European Climate Law. The Commission has come out with the Industrial Strategy for a future-ready economy. The Commission has come out with the Circular Economy Action Plan for sustainable resource use. The Commission has come out with a farm-to-fork strategy in order to promote sustainable food production and consumption, European biodiversity strategy, and so on. All that in a matter of a couple of months, and all that to further support the European Green Deal. From a research and innovation perspective, we also have taken a few initiatives. Soren already referred to a Green Deal call with a value of €1 billion that we are promoting under the still existing Horizon 2020 framework program for research and innovation. Even if you are now running the program in its last couple of weeks and months, and so it's due to finish before the end of this year, we still managed to mobilize resources to the tune of €1 billion in order to further support the policy initiatives. And it covers a whole range of things. It has to do with a cleaner environment, it has to do with healthier cities, it has to do with connecting industry and so on. And each time we see a central role for research innovation to come up with appropriate measures and solutions. I want to draw your attention to one particular part of that call that is dealing with closing the carbon cycle in industry. There's a value of €18 million and with a deadline foreseen for the 26th of January of next year. So there's a major opportunity here to invest in solutions to closing the carbon cycle. What we want to support is really industrial scale demonstration that will demonstrate the feasibility to exploit in an economic fashion, in a commercial fashion, and in a circular fashion, these new catalytic routes for synthetic fuels and chemicals. And then Horizon Europe is coming along. Horizon Europe, as you will know, will be the next framework program for research innovation. If everything goes well, it will start its activities in the beginning of next year. And now what is really so special when we look at Horizon Europe is the whole design, the whole philosophy behind it. We're moving here from being a funder of research to becoming a provider of really solutions to tackle the major problems and challenges under the Green Deal. What is specific here is this notion of sustainable by design. So what we will be looking for is research innovation policies and programs that look at the full picture from the beginning to the end, along value chains, across sectors, but also looking at the impact that our activities will have on the environment, what it means for citizens and consumers and patients, for instance, as well. Groups, other stakeholders. Sustainable by design indeed is an approach where in the context of the Green Deal we are not just looking for safe products and production methods but also for circular approaches and of course it needs to be functional. So the various components of sustainability will be brought together and that is something that we will promote under Horizon Europe. So stay tuned to see what will be coming. More will follow in the next couple of weeks and months. So thank you.
Soren?
Okay. So, thank you very much, Barend. Then we come to the second speaker of the day, which is David Cuesto. He's a chemical engineer from the University of Oviedo, and he is a co-founder of the ODEALS Institute, and he's been in this company for a lot of time, actually 10 years. I met David the first time when he was involved in the MEF CO2 project, which was one of the first projects that we very consciously promoted in the part of the of our activities in the European Commission. And this indeed spearheaded a lot of activities for CO2 conversion. And I think that it's been quite successful, and we will probably revisit that right now. So, David, the floor is yours, please.
David, before you start, can I remind all the other speakers to mute their microphone while they are not speaking? Thank you very much.
Okay, thank you very much, Soren, for your kind words. Quite a lot of time has passed since we met for the first time. And I'd like to share with you to share the evolution of MEF CO2 throughout these years. I think it's quite interesting. So let me start with explaining who has been involved in this project. This started back in 2014 when 9 partners decided to pursue the goal to develop a first carbon capture and utilization project here in continental Europe. This is very important because carbon capture and utilization had been already demonstrated, but we needed to adapt the concept to what's European conditions, continental European conditions. So we decided to go for a concept in which we took 4 key objectives in mind. So we wanted to focus on the adaptability of carbon capture process and utilization. We should be able to extend this concept to any CO2 emitting source. So it had to be, in this case, quite versatile in terms of the CO2 point emission you were capturing. The concept could be even scaled for direct air capture in the future. So it had to be quite versatile. The other thing was it had to be flexible flexible because, well, this kind of concept requires hydrogen, green hydrogen, if it wants to be sustainable. So we need to adapt to fluctuant renewable energy generation. That's quite important. So you need to have a hydrogen technology that allows you to adapt to that. In this case, we used PEM technology. And the hardest thing was to develop a flexible production process. We developed a process that could also change their output according to the availability of CO2 or green hydrogen. So that's not very common, but the process can adapt. Even can go from its naming capacity to a 40%, so that you can adapt the process itself to the conditions of the availability of green energy and green hydrogen. So that was quite well, challenging. And the next thing was to produce a product that was versatile enough to have a huge demand. So we had methanol, because it's in fact it's in the it's produced in hundreds of megatons worldwide. So the demand is high enough so that the carbon capture and utilization has a meaningful impact on CO2 reduction. We would have gone for polymers, but the impact should be lower. So we went for a large volume chemical such as methanol. And as I mentioned, well, we had a first demo running already by the time the project kicked off. But the conditions were from different from what we've got here in continental Europe. We had one of the partners of the consortium had a pilot plant running already in Iceland. It ran on geothermal power. It ran on CO2 from geothermal generation. So it was quite difficult. So we need to move the concept into the conditions we could find in continental Europe. So the concept is what you see here on the screen. We located our pilot plant in Niederhausen in Germany. We use post-combustion CO2 capture already built in the coal fire in the lignite fire plant owned by RWE. We use PEM electrolysis, and we were able to demonstrate that we could produce 1.5 ton of methanol per day, and adapting to the conditions in terms of green hydrogen, green energy availability. So that's quite a challenge, but we were able to succeed and demonstrate it. And since the concept had to be adaptable to many other settings, we iterated again. So we moved from this concept to the concept you now see on screen, which is FRESMI. We moved the concept from the lignite power fire plant to a steel mill. We took advantage of the availability of hydrogen-rich gases in the steel manufacturing of primary steel. So we use it to capture CO2. We use it to separate hydrogen. We use it to transform carbon monoxide into additional hydrogen, and then we produce methanol. And we are right now demonstrating, and we plan to run a ferry that you will see in our last slide early next year. We've been stricken by COVID, but we are now the test pilots started yesterday, so we are on the right path to accomplish our objectives. And we want to thank the European Commission for funding this research. I think it's a clear step on the right direction and in the decarbonization of hard to carbonize industries such as steel manufacturing. Nothing else from my side. Thank you very much for the opportunity to present today.
Thank you very much, David, for a very inspiring presentation. I think that it's very impressive, the results that you've shown with the two projects you presented here. So with this, I would like to give the floor to the next speaker, which is Walter Leitner, who is a director of the Max Planck Institute for Chemical Energy Conversion in Mülheim an der Ruhr. Walter and I also know each other since a couple of years. We started together on the SynFlow project, and we carried on with CO2 conversion also in terms of the Cuesto activities. So with no further ado, I think I will hand over to Walter and let him explain how he sees the future for CO2 conversion and energy use. Please, Walter, the floor is yours.
Well, thank you very much indeed, Soren, for this very kind introduction, and thank you for having me in this group and being able to give a forward-looking view also from the science community on CO2 conversion. And if I can see the slides, we will talk about CO2 for fuels and chemicals using catalysis as the key technology. So if we just remind us quickly about the challenge that is ahead of us, but at the same time also the opportunity, of course, for the fuels and chemical sectors, it's really crude oil that is still the major source of carbon that we're using. And before COVID-19, in 2019, we reached the level of consuming and producing the equivalent of 100 million barrels of crude oil every day on this planet, which means that if you put all these barrels next to each other, they would go 1.5 times around the globe every day if it's really filled into barrels. So as much as we are able to decarbonize the power sector, the electricity sector, it's obvious that we can maybe defossilize, but not decarbonize the chemistry and the fuel sector. We will need carbon-based materials for sure in the chemical sector and also as energy carriers in a lot of the transportation sector. So what are the options that we have? One of them, one very attractive option, is to use carbon dioxide directly. That's what nature does in photosynthesis. It uses carbon dioxide plus sunlight plus water to produce all the biomass, the trees and the plants that surround us. In technology, this is quite difficult because CO2 is a very energy low molecule, so we have to bring it together with a partner that brings in energy to make a driving force to combine CO2 to build it into a product. That's like in real life. You have this lazy couch potato that does do nothing, so you need to combine it with somebody who is very lively, and then maybe that can form a nice couple. But still, they may not actually easily meet. And CO2 is a very unreactive molecule. It doesn't like to form carbon-carbon and carbon-hydrogen bonds. So we need a catalyst to bring these two partners together. If we succeed in doing this, the first option we have is that this partner still comes from fossil resources and we replace part of it with CO2. So the driving force, the energetic driving force, still comes from fossil resources partly, but with every carbon of CO2 that we put in, we leave some of the fossil resources in the ground. The second option, that is that this partner is actually formed from renewable energy, like hydrogen, like green hydrogen, and then this way we can harness renewable energy into the value chain of mobility and of chemistry. And let me just give you one example for the first part, replacing fossil feedstocks, and then move to the second part, harnessing renewable energy. So this is a project that has been mentioned by Soren just before. It's a collaboration of the company Cuesto with RWTH Aachen University and a number of other partners, where these particular molecules, and if you're not a chemist, you don't have to look at them in any detail, but these particular products, which are called polyols, are produced with the incorporation of carbon dioxide as a feedstock, as a raw material. These polyols are important building blocks for polymers that are called polyurethanes, and they have many, many, many different applications. And it's now possible to make these materials by replacing about 20% of the petrochemical feedstock. We still need the petrochemical feedstock, but now about 20% less. And then this material is now tested in a range of real-world applications like soft foams, mattresses, textiles, sports grounds, car parts, everywhere where polyurethanes are needed today. This is being ongoing to test them, and the capacity, the production capacity that was built up to do that is 5,000 tons per year of that. So that's already quite sizable. But the full market, of course, of polyurethanes is in the millions of tons, so much bigger than that. And if we can reduce the carbon footprint by 20%, that's certainly an achievement. But ultimately, of course, we would like to go to a situation where we use green energy as the intake and no fossil resources at all anymore, And just in the talk before, methanol has been already introduced through this wonderful project, MEF-CO2. There is a range of other projects on national and also international level, not only in Europe, also outside of Europe. China is also investing in these technologies to now use renewable energy to generate hydrogen and then combine hydrogen to make, for example, methanol, which is a very important component. And this technology in principle is very much scalable because we make today methanol from the same kind of resources here, but from based on fossil feedstocks on a 1 million ton scale. So we have really here the potential to go into scalable technologies. But on the scientific part and on the discovery part, we can use CO2 and hydrogen to make many more molecules. And of course, society is not interested in molecules as we chemists are, but society is interested in the final products like surfactants, coatings, fragrances, fuels, of course, agrochemicals. And this really opens a whole possibility, a huge range of opportunities to make valuable compounds from CO2 and hydrogen on, again, scalable technologies. Now, let me talk about two aspects here. One is, where do we get the CO2 from, and where do we get the renewable energy from? We have a lot of point sources of CO2.
1 minute.
Just to mention, do you have 1 minute left, more or less?
I'm getting to the. Now the slides are gone, but I can just tell that also with. At least I don't see them anymore. I'm not sure. Can you still see the slides? Okay. So we have enough CO2 from various port sources. We have renewable hydrogen in Europe available in sweet spots. And we have to combine these two things to come together. I will skip over the financial parts and just come back to the point that has been made. We have to bring this to society, to introduce this to society and take everybody along, because we know that especially the young generation will not talk about the technology details, but wants to see the opportunities for the future here. And we can do that. And let me just close with the general vision and ultimately with a quote that I like a lot from both Max Planck and Nelson Mandela. Insight has to precede application. We have to think ahead, what can we do in the future, and provide the technology and innovative basis we are very good at in Europe. And then we have to do it, because it only seems impossible until it's actually finally done. Thank you very much for your kind attention.
Well, thank you, Walter, especially for this last quote. And indeed, CO2 and hydrogen can do miracles. We will see a little bit later what are maybe the obstacles and what we need to really make it a reality at industrial scale. Now, I'd like to introduce the last speaker, so Carl de Maré. Carl is currently Vice President of ArcelorMittal, the famous steel group. He's Head of Technology Strategy for ArcelorMittal Europe, but he is also, and speaking today, as Chairman of ESTEP, so the European technology platform for steel. Carl graduated as civil engineer in electromechanics from the University of Ghent, and he has basically made his whole career in what has become the ArcelorMittal Group, since he started as application research manager at the Sidmar Research Institute, was head of the steelmaking department afterwards, and then continuous improvement and industrial optimization for flat of ArcelorMittal. So he has held the position of CTO at Flat Carbon Europe, and then became corporate technology strategy for the ArcelorMittal Group Europe. So Carl, the floor is yours. We'll listen to your presentation.
Yeah, thank you. Do you hear me?
Yes, I do.
Yeah, then you will also see the slides. Okay. Yeah. Some technical issue here. What do I need to do? Hello? Okay. Yeah. Thank you. I will continue. Joris, do you see the slides already or not?
I think they're bringing them on now, Carl.
Okay, good. But I can already introduce consists of, please. Yeah. I see myself on the
your video open? Your camera open?
Yeah, my camera is open. I see the slides also. It's working well now.
But your camera is not working.
My camera is open. And I see myself on the screen, so I don't know what's the issue. Should I continue with the slides already?
Yes, we see the slide now.
Okay, thank you. Thank you very much. Okay, good. So thanks for the opportunity to speak. Indeed, I'm representing here as ESTEP the steel community. As all other materials, we are facing, in fact, two challenges. Together we represent more or less 25% of the greenhouse gas emissions. However, we don't need only to bring that down to zero. We also have to find ways to produce it in a full circular way, because as you saw, the evolution of demand of materials of the last decades, that will not change. We only see more demand for high value-added materials if we want to make the transition to net zero carbon world. And here I think the steel makers really took a high commitment, and I copied just some of the commitments we did as ArcelorMittal, but that's also true for the other steel makers. We announced that with the steel community in 2030 already want to be 30% below emissions of 2018, which is in fact a 55% reduction versus 1990. And for ArcelorMittal, I think we are the first global steel company who committed that. We not only committed to become carbon neutral in Europe, but even at a global scale. And then the question on what trends do we see, or what solutions do we have in the portfolio in order to reach that goal? Well, in fact, there are three clear drivers, in which we already have seen also in the previous pictures. One is definitely to go to clean electricity, try to electrify, and in our steelmaking vocabulary, we call that carbon direct avoidance, to do the primary ore reduction with electricity instead of with carbon. However, the amount of low and green electricity you need for that will be a constraining factor. So the second point is really circular carbon. As we use today carbon for iron ore reduction for a chemical reaction, we believe that this carbon really can come in a large scale from waste carbon products from society, which will help also circularity for other sectors, and convert that back into chemicals, as we also saw in the previous speech, and also the demonstration of Cuesto. But then third of all, we believe that also carbon capture and storage is important in the short term to help to green the electricity and to help to scale up the circular carbon processes. And in the long term also, if you combine the three together, to create a circular or even a net negative emission. So the challenges, and where we really believe R&D is needed, it's on the scale and on the competitiveness. Steel plants, and there are only a few left in Europe, they are very large scale, very efficient. And so where we need to focus on technology, it needs to be technology which can be scaled up in large extent, and at the same moment also have the potential to help the circular economy in order to create value. Otherwise, or the technology will not be affordable, or the technology will not be scalable. And I have two examples from our steel community. One comes from ArcelorMittal. It's a very attractive and very ambitious project where two technologies are combined, the Torero technology with the steel technology, to convert waste wood into an alternative carbon-containing reduction material for the blast furnace, and then to use the blast furnace gas with a biological catalyst, in this case, with microbes, to convert that back into ethanol. A project which I think is also illustrating the challenges that we had. So it was highly supported by DG RTD in 2015, 2017. However, it was not enough. We talk here about a 200 million euro investment, really, as said by Barend in the introduction, really industrial large-scale demonstration. We had to find additional risk-sharing mechanisms in order to make it possible. And I think also an important element is that the legislation of this type of product, this type of ethanol which is produced, had to be reviewed, and so we needed a review of the RED, the Renewable Energy Directive, in order to make this product possible into the market. And then another example is an example from voestalpine on the need of scale of green hydrogen in order to decarbonize the industry, where for an existing 2 million ton plant, we need to go to a 700 megawatt electrolyzer scale, where today technology is about 10 to even 5 megawatts. So we need here to scale up the technology still with a factor 100 and bring down the costs with a factor 3 to 4. So just to summarize, I think R&D is key. We have technologies available. However, we have to think out of the box. We can't stay within our sector. We need to think on technologies which can be implemented on existing assets, which will create value in society by producing more circular products. And here, I think one of the challenges I still see is that those circular products need to find a proper place in society. So we will need legislation also to promote those circular products, that they are preferred over the current fossil-based carbon products. So thanks for your attention, and looking forward to the debate.
Thank you, Carl, and thank you for keeping your time right on time. I hope all the panelists now have their camera open. I wanted to start with you, Carl, since you finished the presentation. Obviously, we understand through your presentation that the solutions are there for the steel industry, and you must have obviously a strong roadmap in view of the commitment that you are making as a company. So my question to you would be really, so what would it take to make all these technologies really an industrial reality? What do you need as, let's say, external steps beyond what you are doing internally so that it can become a reality?
Well, thanks for the question. Indeed, I mentioned some of the challenges. So the challenges are definitely that we have to go beyond what we do today. And we see that we need to integrate renewable energy strategies with also the production of circular products in order to make it happening. And we need to do that in a multinational environment. So you know that energy strategy is definitely still a member state issue, although the Commission is giving guidance. We see different policies in different member states. With different starting conditions. And secondly, we see also, and that's what I mentioned in my pitch, is that for the recycled carbon products that are produced, there is still a lack of understanding that this is really a fundamental part of a sustainable society. If we produce methanol from CO2, or we produce ethanol from CO2, as in the ArcelorMittal example, we still are confronted with member states who say, yeah, but we cannot support that because that hydrocarbon can potentially be burned back into CO2 if you use it in an application. So I think what we still need is that there is a real serious directive on circular economy, that circular economy is prioritized, and that we don't look anymore as circular economy as a kind of upgraded waste directive. No, circular economy directive needs to be a fundamental part of our industrial strategy.
Yeah, thank you. Sorry, we were interrupted. Thank you, Carl. That gives me an opportunity to turn to Barend. When you listen to the suggestion that Carl made about the circular economy package, but when you see also the additional challenges that he mentioned about, green hydrogen at scale and things like that, beyond the very nice presentation you made of the Green Deal, etc., and all these actions included in the Green Deal, do you see additional major action that the European Commission could put in place to address these particular issues?
Yeah. Well, I like the question because you're putting it as beyond the Green Deal. I think the Green Deal as such is quite challenging. Right. Yeah. But that being said, as Carl also suggested, of course we do need all these investments in research, in innovation, industrial investments. Without that, it will not be possible. And as you know, we're at the side of the Commission, we're promoting some major initiatives there, in particular Horizon Europe. But that is self-evident. I think one area that we really should be looking at and focusing on is also that the one of standardization and the regulatory framework more in general. So I think there's a clear need that we have the proper standards put in place that on the one hand help understand and define what we mean by, for instance, circular products, what we mean, for instance, by decarbonization. I mean, this is very nice and I think very appropriate differentiation that Professor Leitner made between defossilizing and decarbonizing. We should not be confused about these things. I'm a biologist myself. Without carbon, there would be no life. And so decarbonization could be an ambiguous term. So we really need to come to a good understanding that. Carl also referred to the role of member states, and indeed, I think there will be a need for national reforms in these areas as well. Very importantly, I think we also need to invest and engage into a dialogue with social partners. It is something in which we are all together. This is not just about making the industry more competitive. It is also about that. It is not just about making the industry more clean. It is also about that, but it is actually about society and the way we are organized as a society and the things that we value and what is acceptable. For instance, we're all aware of windmill debates, and everybody is in favor of windmills, only not in their own backyard. So these are discussions that we need to engage in and where we need to find common grounds. And then very importantly, I think for Europe as well, is to look at things in an international perspective. We are not there alone. I think Europe, rightly so, should and must take the lead in rolling out the Green Deal. But we can only be successful if we do that in cooperation with our international partners. And so that definitely is also an area where we need to further invest in.
Okay, thank you. Thank you very much. Let me turn to the research and innovation area. Walter, you are a distinguished representative of this World of Research organization, and you have shown us very inspiring ideas to use CO2 and hydrogen. Obviously, there's still work to do, even probably fundamental work to do to achieve this. So, in your perspective, what do you think should be done from this research and innovation perspective to be able to achieve success in this futuristic scenario?
Yes, I mean, obviously we have technologies that are already very advanced and potentially scalable today. So we can talk about like technologies 1.0 or maybe even 2.0, but we also have to look to say this is only the starting point, and we have to develop it further and do fundamental research to understand the basics of these processes, and then be able to come up with new technologies. And in particular, I think one great chance is that we can not only make substitutes for the same compound. So of course we can make methanol and ethanol. That's fantastic, and it should be done and it must be done. But we also can think about new value chains and improved products that may have also better properties than the products that we have today. If we look, for example, on these polyurethanes, on these polymers that are produced on the basis of CO2, there's a very great chance that they are easier to recycle because the new chemical situation makes them easier to break them down, and so they can also go into a circular economy that way. So we can not only reduce the carbon footprint, but we can at the same time improve actually the properties of these materials or of these products. And that's a fantastic opportunity that may not have been so much on the focus up to now, that we can not only do it on a different raw material basis, but also do better than we did so far, which is, of course, then also creating new values and new business opportunities. And that is something that I think we can do from the scientific basis and bring into that discussion. And at the same time, it's very important that we connect with life cycle thinking. We say, is this really contributing to reduced carbon footprint? Is this bringing environmental benefits? And interact with the society. And we can talk later about this connection between science and society. I'm happy to give some examples how that can be maybe done in a more proactive way than it has been probably done in the past.
Thank you, Walter. David, I turn to you. You've been leading and showing us this very interesting, concrete project that deliver results. So from there, you know the intimate details of this project. So based on this experience, what would it take to bring this type of project really mainstream and make it industrial reality?
I think Carl also commented on this. It's a matter of scale. We need to scale the technology in the short term in order to deliver a meaningful impact. So basically what we need is to overcome the barriers for a competitive process. In this case, the real burden is hydrogen. Green hydrogen in this case it's quite expensive to produce. So I think we need to push for a higher scale process. And this for this, the EC has set an ambitious goal for green hydrogen production strategy. We need to advance into that. There are certain instruments such as the European Green Deal, the Innovation Fund, that could further support this first of kind industrial plants. This will contribute to lower the cost of hydrogen, and it will be crucial when it comes to deliver a competitive product. Without that, all the R&D effort that has been funded by the EC will have little impact. So it's now time to go for a industrial scale. We need this kind of projects need some support, at least the first ones. But with that, we should achieve the scale. We should achieve the know-how, and we would have the capability to produce a competitive product. And as Carl mentioned, the recognition of this circular approach needs to be addressed, because at the beginning they will be more expensive, but I think that the public needs to recognize that this is more sustainable, and it needs some support, and an adequate framework should also help. The Renewable Energy Directive should address this. As I mentioned, there are several actions that need to be undertaken. I think it will be possible in the coming years to provide a meaningful impact.
Thank you. I think it's time to turn to the poll. So, Soren, I give you the stage.
Thank you very much, Pierre. Yes, indeed, we would like you to join the polls. There should be on your screen, there should be a button saying participate in the poll. And the screen should turn green or blue as soon as the poll is activated. So then when we've gone through the next round, then we will finish the polling, and then I will try to announce the results, and then we can have a discussion based on those. So I think with that, we should be able to go back to you, Pierre, again, and then have the second round of questions for the panel. It's the first question. It's the first interactive poll about the carbon neutrality reality in industry.
All right.
Pierre, back to you.
Should you raise a question? I don't see anything on the poll. Anyway, in the meantime, I can continue and maybe with a second round of questions for the panelists. And going back to Carl, there is a question in industry that we are always asking ourselves, and I guess steel industry is also concerned with this. You're obviously, open to global competition. So how do you see a company like ArcelorMittal and particularly the decarbonated plant navigate through the transition, remaining competitive against, those players who may not apply the same standards or be constrained by the same willingness to decarbonize?
Yeah, thanks a lot. Yeah, that's really one of the key questions that we already put on the agenda since more than 5 years as a company, but also together with the Steel Association Eurofair. I think what we need, definitely if we talk about climate, that this is really a global problem. And steel particular is a product where you see that all emissions are in a very primary state of the value chain. However, that once the product, and that's then the semis, the steel semis, is produced, afterwards you do not have really still significant amount of CO2 emissions, and that semi-product is very easy to transport. So therefore, I think the steel sector, perhaps more than others, is vulnerable to leakage. And we have seen that, and we see it still today, that indeed, although steel consumption in Europe goes up, if you look to the total consumption of products, but more and more the products are imported. And in the beginning, there are the steel products which are imported, but we also see the tendency that it's the finished product with a high added value which started to be imported, and that can never be the goal. So I think what is really great, and that I think was a trigger for the steel industry to say, okay, we also will commit to very ambitious goals in 2030 and 2050, linked with the Green Deal, where in the Green Deal, we really start to talk about a carbon adjustment. A carbon adjustment that we take full responsibility also for emissions which are done outside Europe for products which we consume, which we import, and that we take there the full responsibility for. I think that's great. That again triggered the steel makers to really step up their ambition. However, we still need to do a lot of work again on how this is done. How is this implemented? How do we treat the carbon which goes into the ethanol or in the methanol? How do we make sure that an imported steel product is treated on a level playing field? How can it then be combined with the existing ETS scheme? So a lot of questions. What I see that we need to advance on that. We need also to advance on this large-scale demonstrations. I think we need also to think on for some industrial zones which are focusing on those technologies, why not creating also a kind of free rule zone as it is in some areas for renewable electricity production, Pierre, that we really can advance in parallel with the industrial demonstrators, that they have a special status because they are first of a kind, and they of course then need to share all the results. But I think that in parallel with also a strong and a correct carbon adjustment at the borders is needed to keep industry here and to have a sustainable future, and also to create the jobs that we think are needed in order to have a wealthy and a comfortable life. So I think those two elements have to be designed in the next year.
Thank you, Carl. A very interesting perspective and comprehensive. Soren, I will give you the stage. I think you need to read the poll question.
Yes, I heard that too. So the first poll question is carbon neutrality. Is that a reality in industry? Is this possible at all? And there are four possibilities for answers: is yes by 2030, yes by 2050, by 2070, and not at all. So these are the polls, and I think you can already see them here on the screen. So it seems like the majority of the audience thinks that carbon neutrality in industry is indeed possible by 2050, which is also the ambition of the Green Deal. So that's nice to see that we have a receptive audience in that regard, and that they agree with us on getting there. I think then we can open for the next poll, and then at the same time we can go back to Pierre. So the next poll, which is what is the biggest hurdle in achieving climate neutrality in industry by 2050? And again, there are four questions, but we will take those after the next question. Pierre, over to you.
Yeah, thank you, Soren. So I will turn now to Barend again, and we've talked about competitiveness, and you mentioned, Barend, also in your first question, the importance of reaching out to the international world, because obviously Europe is not alone in influencing climate change. I think we represent only 8% of CO2 emission. So clearly we have a role model to play, but how do you think Europe could foster the other regions in the world in the direction of carbon neutrality? So what other actions do you think you should take in place at worldwide level to reach this influence and fostering?
Okay, thanks for that. Now, let me start from my comfort zone, and that's the world of research and innovation. So clearly, research innovation always has been a great catalyzer for integration across borders, for working together across borders. So in the field of research innovation, definitely there's tremendous scope to collaborate. And the technological challenges are diverse, but many are common. And by pulling our resources together, our ideas together, our brains together, we can achieve so much more. So that is an evident field where we can try and achieve that. It's not always evident. Europe has to do this in an intelligent fashion. And with that I mean in a way that we really and truly can create win-win situations. So that's not just Europe exporting its technology to production sites outside of Europe. That is a two-way street. But that is a very evident component of international cooperation. Carl already dwelt quite extensively on the carbon border adjustment mechanism. I think basically we agree with the philosophy or the ideas that he has proposed there, but of course the proof of the pudding is in the eating, so we'll have to see how it will further work out in practice, but very clearly the carbon border adjustment mechanism can and will be an important lever in this. Europe evidently, as a whole, has actively and enthusiastically subscribed to the Paris Agreement. And in fact, in its international trade negotiations, that is always a key component that is put forward by Europe, by the European Commission. So when we are engaging in bilateral agreements with other regions in the world, then we try and do it in such a way that we create a level field in terms of observing and contributing to the objectives of the Paris Agreement. Also, in the context of OECD, I think we have a platform where there's tremendous scope for collaboration, not just between the level of member states of OECD. There also industry is playing an active role there. The scientific community is playing an active role there. So it's a great place to come together. So there's all a range of things that we can also refer previously to the development of standards. And indeed, I'd like to further expand that to the development of criteria for what I described as sustainability by design. I think at the end of the day, the alpha and the omega, the beginning and the end of anything that we try and achieve is to come up with truly sustainable production and consumption processes. And so there we need to really agree what we mean by that. Now we are going to achieve that. And the only way to really be successful there is to bring this and to develop this at an international level. So there again is great scope for collaboration at the international level.
All right, very clear. Thank you. Soren, we have the result of the polls.
Very good. So the next poll is what are the biggest hurdles in achieving climate neutrality in industry by 2050? And there are four answers possible. A is competitiveness versus non-climate neutral players, availability of the green electricity, appropriate technology solutions, and social issues related to unfavored areas. And this is a little bit of a surprise. It's very balanced. So we can see that most people do not think that it's competitive versus the outside world or third countries, but it's more like the social issues which are related to unfavored areas. And the two others, the availability of green electricity and the appropriate technology solutions, are sort of tied in between. So that is already a very interesting feedback that we have from this audience. So with that, I would then open for the next question or the next poll. What do you think the social impacts of climate neutral industry will be? And then we open the poll, and then we can take the next question in between.
Well, for the sake of time, Soren, maybe I would suggest we focus on the poll. I think the answers are coming quickly. Maybe if we can see the results live.
It will still take a few minutes normally before they come. Okay, all right. So I will continue with the panel discussion and turning to Walter again. And you mentioned about the need for still fundamental research. And on the other hand, I think when we talk about decarbonization of industry, where a lot of people, including me, by the way, are insisting on the very high importance to really scale up now what we have already, because we need to be ready by 2030. So there will be a lot of priority on these scaling up activities at higher TRL level. But at the same time, I think you rightly so mentioned the fact that we still need to focus on fundamental research. So how do you see basically longer term the place of this fundamental research? How do you see that it will be still supported and not be forgotten by all these different funding tools that are in place?
Yeah, I think this is a very important issue, because as much as I agree that we have to move on with the scaling as quickly as possible, it is clear that the fundamental research has to develop also, because we can only build on what we done probably 20, 30 years ago today. And that will continue to be the same stage. Now, Europe has some funding schemes for fundamental research. The ERC grants are certainly one vehicle or one tool that is extremely successful. But it's also nice to have networks, to have scientific networks. We spoke a lot about the internationality of science, and these programs where one could collaborate with universities, with fundamental research institutions in other countries were very successful. The SynFlow project that was mentioned by Soren. And these are on lower technology readiness level. And that maybe is something that is currently, there is more, I think there should be more attention to that, to fill the pipeline and then go to the next level, of course, but also fill the pipeline on the international level and not just on the individuals, like through the ERC grants, but also to scientific networks that have a connection to industry, that have a clear focus on what is needed, but that also allow for more diversity and more fundamental insight, and that way also strengthen the scientific community within Europe across the board, and not just at the places where, like Max Planck or so, where it is already fantastic, hopefully, at least from my point of view. But generally also that way bring up the level of science and education all over Europe through these networks.
Okay, very good. And fundamental research is also part of this technological sovereignty that we've been talking about. Back to the poll, and that would be probably the last question of the poll that we review together. Soren?
Indeed, yes. So we are seeing the last poll that we are bringing today. We are skipping the last one because we're a little bit late in the session. So what do you think the direct social impacts of a climate neutral industry will be? A is more jobs, B is neutral but vast job transfer, geographical, and C, less jobs. And it seems like the audience think that the neutral but vast job transfers geographically will be what comes into play here, and that is also a very interesting job, a very interesting thing. Even though I would have hoped that people would think that we would get some more jobs, but I think that comes with time. So with that, I think we can go to the last question, and then we would like to take a question from the audience as the last part of the session. Is that okay for you, Pierre?
Yeah, well, if you don't mind, I think because time is running and it's important also to take questions from the audience, and I see a couple of those here, and so I would suggest to go ahead. And I see one question here, and sorry, Cuesto, for missing one of your questions, but there is a question from the audience that I read now. We can see that many speakers emphasize how important new markets for green products are. So how can such markets be created as soon as possible? Do such markets be industry specific, or can we imagine addressing green products in general? So I don't know who wants to take first this question.
Yeah, Pierre, I can perhaps take a first answer. Yeah, I think the products, we should indeed really see this as an opportunity. Also, to answer the last, I was a bit surprised. The last poll is very interesting to see how we still believe that we will destroy jobs by a sustainable strategy. So I think the key point is, if we really believe in circular products, and if we really believe we have to replace the primary resources for the products, which are very easy to capture. You can do it at large scale. You have natural gas, oil, iron ore mines. So this is all done in a very efficient way. If you replace that with really secondary resources, waste, carbon-containing resources, I really believe that this will be a job creator. We will convert, instead of importing primary resources to Europe, we convert that back into labor to collect waste, to be smart, to add artificial intelligence technology, to be as smart as possible on all those waste streams and convert them into products. So, and therefore we need to give priority to those products which are made out of recycled carbon. And I think it's done in the fuel directive, where, and also in the Renewable Energy Directive, we now see a new category of recycled carbon, liquid fuels, which are eligible for a mandate in the fuel sector to fulfill that mandate. I think the same is possible in circular steel products, in circular cement products, in circular polymers, that they need to get priority over the other commodities if they are produced, that there is a demand created by policies who promote them over the fossil-based primary resources materials. I think it's really possible. Definitely in productions where you have massive volumes, where in polymers you are anyhow mixing and using multiple resources in order to make a product. I think here creating standards which look to the recycled carbon content of a material can be done, and we can gradually increase the standard to have a mandate where more and more of the product need to be blended into the rest of the product as the supply is increasing. So probably this is an advocacy to really have a circular economy package and not think that this is a waste directive package.
Thank you, very good. I don't know if there is anyone who wishes to add anything from his perspective.
I could, if that's okay.
Go ahead.
Barend, please go ahead.
Yeah, okay, thank you. So from a Commission perspective, so the question was about what can be done to help develop and create these new markets. And just want to point out that at the level of the Commission, we are actively investing in this as well. We're doing this through so-called public-private partnerships. One example could be A.SPIRE, but I will not dwell on that one for obvious reasons in this panel. But I'd like to give two examples. One is FCH, fuel cells and hydrogen. And so what is happening here is here the industry is pooling resources with the European Commission in order to not just to develop the necessary technology, in order to validate this technology, in order to upscale and upgrade this technology, in order to bring this technology to higher TRLs, so technology readiness levels, but also to try and help promote investment in the necessary infrastructure there. Another example is BBI, the Bio-Based Industries a joint undertaking, again, a public-private partnership where industry and European Commission are coming together, investing into a large-scale program where indeed a very serious attempt is made to try and find alternatives for fossil resources for the production of fuels, chemicals, materials, and so on. And by doing so, we do hope that indeed we can accelerate the creation and development of these markets.
Okay. So, Soren, do we have another question from the audience?
I still cannot see the questions. Do you see any coming up? Otherwise, we could just see if any of the other panelists had a question.
Well, I see one question that is coming from Austria, and that gentleman or lady is mentioning this. So what I missed in the discussion so far is the very important aspect of technology transfer to industry. So I assume they mean technology transfer from research world to industry, not just of novel, innovative approaches, but also of existing valuable approaches and modern, efficient, and resource-saving technologies. So I'm not sure what the question is exactly, but I assume they talk about, put the question of activating more technology transfer from research organization to industry about these efficient and resource-saving technologies.
Maybe I can quickly
to answer this. Yes.
I was involved in such a transfer activity with the company Cuesto on these CO2-based polymers. And really the key is a very trustful collaboration between the two partners. So in this case, it was a joint research center that was founded by the company plus the university, located at the university in a very open space. And it was beneficial for both parts because on the one hand, the target was very clear. It was clear to the scientists what are the product properties that would make a good mattress, that would make a good glue, adhesive, whatever, and then target the research. Not only on improving the existing technology, but making it possible to have these properties in a new product. And this is very important. This is to have collaborations that are on eyesight. So it's not that the science becomes like the supporter of the industry, but it is a face-to-face collaboration. And very often it's good to have a joint infrastructure, somewhere where people come together from both sides, or a network, a good collaborative network. And that's where the EU projects are really very, very beneficial to create that sort of atmosphere where one can openly discuss the problems and bring the ideas forward without having the fear that they are then taken away and things happen. So that's, I think the European networks are very, very successful in this, but there is possibility to do even more and to do that even better.
Mm-hmm. Mm-hmm.
Okay, thank you. So I think we're putting
just to
oh, sorry. Go ahead.
A short comment.
Very quickly. 1 minute.
With Walter. And of course, in 7 minutes, this is difficult to highlight that the project that we are currently doing are a result of all those technology transfers. And what I think is strong in Europe is that the European Commission already since, and Barend, correct me, I think 15, 20 years, in the dialogue on what innovation do we need, they speak only with those technology platforms. I think the role of the technology platforms is key. You mentioned already ASPIRE. I'm president of ESTEP, the European Steel Technology Platform. Everybody is represented, customers, suppliers, producers of steel, but also all the technology providers, the research institutes. And like Walter says, this is really the forum where ideas can be exchanged in a correct way, where you can see at what level of TRL, what technology is available, and how we can help by working together to bring it to the next level. So I think the technology platforms are key and are extremely active in all areas. Yeah. And if you see a project, it's a result of that technology transfer. Yeah.
Okay, thank you very much for this last comment. So I think it's time to wrap up now. We have just 1 minute left. So Soren, what would be your summary of that this interesting discussion?
I will try to make a super fast summary of this whole thing. I think it's been a very impressive presentations that we've seen, and some of the key points that we can take home with us is the need for standardization and having a regulatory framework that is promoting the competitiveness of the industry, but it's also the international collaboration, which is very important, as seen by most of the people in the panel. We need new value chains, and we need to see that as an opportunity, think out of the box, and to get better products. Then we also need the scalability of the process and the whole part from getting from fundamental research up to getting products on the market. I think that overall we've seen positive feedback from the audience on the polls, and also the possibility to contribute in a meaningful way. So with that, I would like to give the last word to you, Pierre.
Yes, thank you, Soren. You summarized very well everything, so it's difficult to add on this, but just very briefly, I think we can say, yes, it is feasible. We have seen that through the polls that people are convinced about this. We have the solutions. We understand that the scale-up is very urgent in a lot of supporting technologies. Collaboration has been again highlighted very much, and I think the full innovation chain needs to be activated from fundamental to transfer from research to industry, and the strong scale-up that is needed to show a demonstration. And the international dimension will remain very important in a reactive way, so protecting, but also in a positive way, fostering and influencing the rest of the world to go into the same direction. So with that, I would like to thank very warmly all the speakers for the interesting discussion, and say to the audience that all this has been recorded and will be available for the next 7 days. Thank you very much to all. Take care and be safe. Bye-bye.
Thank you very much. Bye-bye.
Thank you.